So our first word on the back of our notes is segment. It is part of a line. It's like you took a line and you chopped both ends off. Chop them off. Like sometimes when I'm cutting up celery, I cut off the two ends of the celery because the ends are kind of gross. You want to have like a fresh one. So I'd be making a segment. How many points are in a segment? Do you know? It has two end points. Someone said two. I agree. There's two end points. But what's happening in here between those end points?
Affinities.
There's more points and more points and more points, right? Point, 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 point. It's just a series of points. That's what a segment and a line are. They're a series of points. So how many points are in a segment? Infinite. Infinite number of points. But it does only have two end points. And that's how we name a segment. We use its two end points, and that's how we know what to call it. That is segment DE. And that's how you name a segment. Okay? Look at these three objects and decide how they're the same and how they're different. What are those three objects? Because it's important.
Ooh.
There's only subtle differences. What do you think?
I know the answer.
What? Go ahead.
One starts from a certain point. One is continuous.
Uh-huh.
And that one is.
One is a line.
I don't know that one.
One's a line and one's a segment. Well, there's another one. What's the other one? Array. Array.
Also has a name.
Oh, it does have a name. It has a name. So what's the opposite of infinite? I was just wondering.
Single.
Take infinite and take off the in. Finite. Have you ever heard the word finite? No? It means that it doesn't go on forever. There's a certain number, a certain amount. So this would be infinite, and the other one, you could maybe call it finite. Okay, so whoever... A ray of sunshine, the sun is the end point. It all starts at the sun, and then they go on forever and ever and ever in one direction. Do they go on in 10 directions? No, just one direction. One direction. So here's a picture. This is ray FG. And the thing about ray FG, the thing about rays, is that the order matters. I cannot call this ray GF. Why not? Right. It is only going in one direction. I have to start with the end point. Isn't that kind of like weird? I have to start with the end? What? It's called an end point, but it's really the beginning. You have to start where the ray begins. So that is ray FG. That is not ray GF. Okay? And when we write these right here, when we write these, we're going to be picky. The arrow always has to point to the right. Very good. The arrow is always going to point to the right so that no one gets mixed up or confused. So what was the real world example? Sunshine. Sun rays. Here's another good example of a ray. See if you can figure out what I'm thinking of. It is in Star Wars.
Lightsaber.
Ah, you got it. A lightsaber. Don't you agree that that starts and then goes on forever in one direction? Yeah?
Actually, it's strictly.
So there's my sunshine example, and here's my lightsaber example. Anyways, that's what you should think of when you think of ray. If you're a girl, you can think of sunshine. If you're a boy, you can do the lightsaber, whatever you want. Okay, who had parallel lines? I want you to think same direction. Parallel, same direction. It's two lines that are traveling in the same direction. Will they ever meet? Will they?
No.
Never. That's the thing about parallel lines. They never intersect. What's the first word in that definition? Coplanar. That means no matter what, we have no choice. We could always put a plane through parallel lines. Always, every time. You can never give me a pair of parallel lines that I couldn't stick a plane through. So they are in the same plane. Here's the symbol for parallel right there. It's just two bars. So this sentence says, line HI is parallel to line JK? Hi, just kidding. Okay, trying to spice it up a little bit. What's next? Oh, there's another real world example. If you needed another one, you could put skis, or you could put railroad tracks. Because if those weren't parallel, what would happen? If there's a kink in one of the tracks, the train would crash. Totally. That sounds dangerous. Okay. Oh, why am I at skew? So perpendicular, make sure you're writing it in the right spot. Lines that intersect to form right angles. That was my bad. I was jumping the gun. Perpendicular, lines that intersect to form right angles. It's kind of the opposite of parallel. Parallel means they're going in the same direction. Perpendicular means they are going in opposite directions. One of those lines is going north-south and the other one is going east-west. Another example of perpendicular lines would be an intersection. I mean, we all go through intersections every day, right? A lot of times the streets are perpendicular at the light, at the intersection, or at a stop sign. A lot of times they're perpendicular. What is the symbol for perpendicular? You see it right here? That symbol? Upside down, capital letter T. That is how you communicate perpendicular. Did you know that mathematicians are lazy? They don't want to write the word perpendicular. How many letters are in the word perpendicular? 13. They don't want to write 13 letters every time they want to say perpendicular. So instead, you just put an upside down letter T, and you don't have to write perpendicular ever again. Wow. Awesome. Another real world example, I just said the crossbars in a window, because you also see windows everywhere. All right, let's go backwards, since Miss Tanton messed us up, and let's go to skew. Is this a new word for you? It was new for me, skew. It doesn't have an R in it, just skew. Those are non-coplanar lines that do not intersect, and I bet you're saying, that makes no sense to me. That means nothing to me, non-coplanar lines that do not intersect, so I'm going to hopefully help you out a little bit. I'm going to let you write this down first. AB and CG are skew. So the only way to show you skew lines is I have to show you a 3D figure, because I can't show you skew if I only have a 2D figure. So AB is this one, AB, and CG is this one. They will never meet for all of eternity. They will never meet, but they're not in the same plane. They will not intersect because one's in the front and one's in the back. Okay, so I want everyone to put your writing utensil down. I know you don't have a real world example for this yet, I know. Put your writing utensil down and show me with your arm, show me parallel. Everyone do it, show me parallel. Show me perpendicular. Not this, that's just intersecting. Perpendicular. Okay, now show me skew. Do you know what skew is? Take them apart, very good. Take them apart like this. Now we look like we're doing karate. Ready? Parallel. Perpendicular. Skew. Perpendicular. Skew. Parallel. Yay! Good job, guys. Thank you for humoring me. Here is a real-world example of skew lines. Highways. Overpasses, actually, kind of. What would happen if these roads, these bridges, were not skew? What would happen if they intersected? Once again, lots of car crashes, right? It's important that the person constructing those knew what skew meant. This one needs to make sure it goes above this one, and they need to never cross. That's what skew is. They never cross, and they're not in the same plane. They're on two different levels, going different directions. All right. What's up next? We're going to do the right one next. Congruent segments. That word should be an old word. You should have heard that before. Congruent. Congruent is just like equal, except we use it for objects. Segments that have the same exact length. Congruent segments. They have to have the same exact length. What would be some examples of congruent segments? What about these two markers? Are these congruent segments? Are they the same length? Yeah. They wouldn't fit in the box if they weren't the same length. What else? I made spaghetti last night. And when I was pouring all the spaghetti into the pot, I noticed most of the spaghetti piece noodles were congruent, right? Yeah, what else?
Cut your hair straight across.
Oh yeah, cutting your hair straight across. Making most of those strands congruent. What else? These 2 meter sticks, since they're both exactly 1 meter, they're congruent, right? Congruent. Okay, what's the symbol for congruent? We talked about this in the warm-up yesterday. And equal sign with a squiggly on top. Or if you're in Spanish, it's called a tilde, right? Is that right? Tilde? Why aren't y'all acknowledging me? Yes? Y'all are in Spanish, right? That's a tilde. Like, I don't know anything yet. I'm in Spanish too. All right, last person. I want you to think middle. Midpoint, middle. Midpoint, middle. Midpoint, middle. A midpoint is a point in the exact middle of a segment. So B is in the perfect middle of this segment. I put tick marks to show that, yep, this side really is the same as this side. If I gave you a segment, how would you find the midpoint of it? What are some ways you could find the middle of a segment? Give me different ways. You could measure it and divide it by 2. What else? What if I gave you a piece of string and I said find the middle? What should you do with that? You don't have a ruler. Darn. Fold it in half. And that would help you find the middle. Good. Very good. Okay. I have an answer.
Okay, it's not nothing with math. Do you have school Monday?
We do not have school on Monday because it is Labor Day. Do we know any more real world examples of a midpoint? The one we were talking about was, you know when you're hanging a picture, like when it has a string like this? You sure want that nail to be the midpoint of where you want to hang it, right? So that was their example. What other examples? Why would you ever need to know the middle of something? What do you think?
It's not a real world example, but it just kind of reminds me of median, like with numbers. And you know, like to find
Very good. From algebra, when you need to find the median, that's awesome. That's the midpoint of a series of numbers. Cool. Sam is full of our real world examples. What else? When you're trying to share something, you cut it in half. Yeah, that's kind of like bisect. That's finding the middle of it. Very good when you're sharing something. Okay, the next thing I want to go over real quick, you're not going to find this anywhere in your notes. Everybody makes a sleep. Oh, no. You're not going to find this in your notes. But I do need you to know when you're writing math how it's supposed to look. When I'm writing a point, y'all already know this. How's it supposed to look? A point. Capital letter. Give me a letter. A. So I'm not talking about drawing a picture. I'm talking about writing it in a sentence. Writing it as an answer. So a point, you name it with a capital letter. How do you name a line? How many letters? 2 letters. Give me 2 letters. AC, okay. And then how am I supposed to tell you that I meant for that to be a line? Put the line on top. What about plane? How do I name a plane? Oh, how many letters? 3 or more. 3 or more. Let's get crazy. Let's go to a different part of the alphabet. M-N-O. Do I put any symbols over it? Because I've seen some of y'all do that. Please don't. Don't put a line over it. Don't put any symbols. 3 capital letters in a row already means it's a plane. It already does. Do you put commas between these? No, actually. Because you're not listing points. You're naming a plane. You need to pretend like those are super glued together. They're all one thing. All right, what about a segment? Give me 2 letters. We already use A like crazy. Stop using A. Huh? ZX. I heard Z, X. How do I tell you that that's a segment? Just a little bar on top, right? No arrows. Segments don't get arrows. They don't go on forever. What about array? FG sounds good. To the right. I love it. Y'all are paying attention. What does congruent look like? What does the symbol look like? And equal sign with a squiggly on top, because that's the official word is squiggly, right? No. Parallel. How do I show parallel? Bars, lines, whatever you want to call them. Perfect And perpendicular is an upside down capital letter T. Awesome. Okay, we are in your next page on your notes. Vocab is over. The back of your posh. Let's look at it.
Oh, I was just saying that with rays and segments, we were doing inequalities of towards the plane and algebra. We saw a lot like with an endpoint and an arrow going forever.
I love it. You were wondering if what?
If they're related.
Yeah, that would totally be a ray. When you're doing an inequality and your answer was x was greater than 1, you would put an empty circle and then you would go this way forever, right?
Yeah, they have ones with also like lines with arrows going each way.
Yeah.
And they have ones with endpoints.
Or like all real numbers. Those are totally rays. That's an awesome example that you've seen in algebra. That's great. Okay, we're going to skip that top portion that says parallel versus skew because we already did that with our arms, right? We already did karate. You already know. So now we're going to practice just naming them. So segments. Let's name 3 different segments from that picture. Give me a segment. What? Okay, you can't name it with 3 letters. What? MR. That is the shortest segment you can name up there, right? MR. So write it down. We're just practicing naming. Yeah. Can you go to the restroom? Oh, do you have an Eagle Buck yet? Because those are your passes. Just put your name and the time, and you can go. What's the longest segment we could name? Name the longest segment up there. LR. Now, just a second. I don't know if I've talked enough about this. Can I say LR or RL? Are those interchangeable?
Don't matter.
Yes.
They actually are interchangeable because do you agree that LR is the collection of points from here to here? Is that the same as the collection of points from here to here? Yeah. So segments, these, order does not matter. When we get to rays, the order does matter. But for segments, I don't care what order you name them in. Just put your name and the time. And you can go ahead. And then what segment have we not named yet? L, M. There we go. Okay. Moving right along. Rays. How do we name a ray again? Pretty much we could name these and then just put an arrow on them, right? We could copy what we already did. MR with an arrow on top. We could do LR with an arrow on top. We could do LM as long as we put an arrow. Uh-oh, they want us to name another one. So MR starts here and goes there forever. LR starts over here and goes there forever. LM, ooh, guess what? LR and LM are the exact same ray. Can you see that? It says start at L, go through R, and continue forever. And this one says start at L, go through M, and continue forever. So these are actually the same ray, which is fine. Let's name one more. RM. RM and RL are going to be the same, so it doesn't matter. RM, which is a totally different ray from MR. Those are totally, completely different rays because you start in different places. And I have officially drawn enough on that page. All right, here we go. I gave you a 3D figure, a rectangular prism to be exact, and I want you to name all the segments that are parallel to GJ. On your paper, go. Name all the segments that are parallel to line GJ. So you can call them a line or a segment. I don't really care on that one. You can do lines or segments. It does say to name segments, so I guess we should do segments. Jose, can you go write one on the board? And Chris, can you go write one on the board? A segment that's parallel to GJ. Thank you. I'll give you a little bit more space. There you go. Wait, put something on top of it or else it's like naked. It's leaving the house without clothes. There you go. Thank you. Good job, Chris. AD is parallel to GJ. That is right. That's hard to say, GJ. B C, ding, 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 is parallel to GJ. Do we get this? Do we get parallel? Let's move on. Miss Stanton, you're boring us because it's too easy. Okay, let's move on. Ooh, we want to name the segments that are skew, practicing that word, skew to GJ. So we're still dealing with GJ, but now we have to pick segments that are skew. So we want to pick ones that are never going to cross GJ. Never. Never going to hit it. Yes, ma'am?
Never mind.
No, you can ask.
I was telling you
That someone was at the door. Okay, I heard him. A segment that is skew to GJ. Never going to touch it. I want Zaya and Lillian to go answer that one. What? Which one are you thinking about doing? Either one? Name me a segment and let's see if it's skewed. Name a segment. Give me 2 letters. No, tell me 2 letters. Give me 2 letters, please. BC. That's parallel to GJ because GJ is going straight up and down and BC is going straight up and down. We're doing this one now. Skew. So give me one that wasn't already said. HI is also parallel to GJ.
DC.
I'm asking Zaya. What do you think?
I don't know.
Okay, give me 2 letters from this picture. Don't look at me. Look at the picture. Give me 2 letters.
Okay.
You're looking that way, that way. Push picture. Just give me 2 letters. From the picture. Why are you looking at me?
Because.
Give me 2 letters.
AB.
AB, all right. Is AB skew with GJ? Are those touching? AB and GJ? No, this is 3D. Remember, it's 3D. This is in the front, and that's in the back. So she's totally correct. AB is skew to GJ because they will never, ever, ever meet. AB is correct. Do you have one, Lillian? DC? Is DC ever going to touch GJ?
No.
Never. They're in 2 totally different planes. So those are both correct. Did anyone write something different and you want me to check and see if you're right? Yes, ma'am. CI. Ding, ding, ding. That's correct. Who else? BH. Ding, ding, ding. Also skew. Anyone else?
There's more.
What about, did you ever think of this? What about DI? What about DI? Did you ever think of shooting through the box?
No.
Think outside the box, guys. Literally.
A,
DI is skew to GJ. You're totally welcome to shoot through there. Okay. Last one. Name all segments perpendicular to GJ. Perpendicular. All segments that make a 90-degree angle with GJ. Alexa, give me a segment that makes a 90-degree angle with GJ. Since this is a box, all those angles are 90. So actually you can pick any line that touches GJ because it's going to touch it at a 90-degree angle.
with this one, you have to say 3 letters.
Never, ever, ever name a line with 3 letters.
Okay.
So some examples would be GH. Anything that has a letter G in it or has a letter J in it will work. GH, GA, JD, JI, JC, GB. All those will work as long as it has a G or a J. Because if you want to be perpendicular to this, I'll highlight all the ones that are perpendicular. Ready? That one is, that one is, that one is, that one is. And then you can go crazy and go through the box, but you don't really need to. Okay? Is that okay? Are we almost done with notes? How are we doing on notes? Ooh, now it's telling us to name not lines, but planes. How do you name a plane? Did you forget yet? How many letters? Tripod, 3. Name a plane with 3 letters. So I want parallel planes. I am going to name a plane, and I want you to name the plane that's parallel to it. A, G, J. Name the plane that's parallel to AGJ. Write it down. What do you think, Jacob? Yep. BHI. AGJ is the left side of the box. Here it is. Dun, 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 dun. Which one's parallel to that? Well, the right side of the box would be parallel to the left. So the right's going to be parallel to the left, the top's going to be parallel to the bottom, and the front is going to be parallel to the back. Okay. Look alive, guys. Look alive. Name two lines that are parallel to plane GJCI. Do you see how you can sometimes use 4 letters to name it? That's A-okay. So,
AB.
okay. What plane is DJCI? The bottom. So we want to be parallel to the bottom, but we want to name a line. So any line that's in the top would be parallel to the bottom of the box. Any line that's in the top. Name a line that's in the top. GH, is that what you said?
AB.
BH, AG, AB, all of those. Yep. Any one that is in the top. Doing good. Whoa, what's going on here? What was what? What was 3? Name all segments. Oh, it was any of the purple ones. You could name any of the purple ones. What is going on here? What do you know about plane A and plane B? What word would you use? They're parallel. They're going in the same direction. And then this one's just intersecting. Oh, we already answered it. Sorry. Which pair of planes are parallel? A is parallel to B. Which pairs of planes intersect? B and C intersect. There's no symbol for intersect, so I just put a comma. A and C intersect. Which planes intersect in line MN? Because remember, when 2 planes cross, you get a line. So which 2 planes are crossing to get MN? Got it? A and C. Which planes intersect to get RS? BC. That's all we have to say about that. Name a pair of parallel planes in the classroom. We're going to go all the way to the exit ticket. Ready? There you go. Exit ticket. This will earn you your worksheet.